During that awesome period in ancient Greece when we had the rise of rationalism as a source of knowledge, Aristotle formalized deductive reasoning. He set out and he thought, okay, when we're reasoning, what exactly are we doing and how can we lay it out in a way that we can examine arguments carefully to see whether we're correct or not? And he came up with what's called the syllogism. What Aristotle said was that to answer a question when you're making an argument, you should approach it in a very standardized way. The first step is to state the general idea or the concept that you're using to make your argument. He called this, or we call this, the major premise. We symbolize it with P1. Then you are to state the specific detail or the fact that you're linking to this concept. This is the minor premise, or P2. And finally, you state the conclusion, C, that logically follows from the linking of the major premise and the minor premise. And this is the detail or the fact that must be true based on the general idea and the specific detail. So let me give you an example that Aristotle actually used. Here's a major premise. It's a concept because it's true about a broad part of reality. All humans are mortal. They die. The minor premise, the specific detail, is that Socrates, one particular fellow, is a human. The conclusion, therefore, follows that Socrates is mortal. Okay? So general concept, all humans are mortal. Specific detail, Socrates is a human. New specific detail that you now know, Socrates is mortal. Here's another example. All cats have claws, and we're not going to worry about the idea of cats being declawed or mutants, but in general, in the normal course of events, all cats have claws. That is a major premise, P1, because it is an idea that applies to all cats. A specific detail is that this little cutie here, Kepler, is a cat. That's our minor premise, P2. It's very specific about one particular cat. Therefore, what do you know without being able to actually make that observation? The logical conclusion that follows is that Kepler has claws. That follows logically from the major premise that all cats have claws and the minor premise that Kepler is a cat. Notice that mathematical calculations are actually deductive reasoning. When I ask you the question, Altair has a parallax of 0.195 arc seconds, how far away is it? I am asking you to use deductive reasoning from a general concept and the specific detail that the parallax of Altair is 0.195 arc seconds to give me another specific detail, which is the distance of Altair. And you're using that by combining this specific detail with the general concept that the distance for any star in parsecs is equal to 1 over the parallax. So this is the general concept, the major premise, because this is true for all stars, all objects in space. This is the minor premise, the specific detail that we're linking to this major premise, and this is the conclusion, the very specific detail that follows from that. And this is why we insist that when you do a mathematical calculation like this, you lay out the equation, the substitution, and the solution, because that's the full deductive argument. Major premise, minor premise, and conclusion. So P1, P2, and C. So try these. See if you can figure out what the conclusion is that we would draw from this major and minor premise, and make sure that you understand why the major premise is general, is an idea, and the minor premise is a detail. If you need to pause the video, go right ahead. So, major premise, more powerful stars have a lower absolute magnitude than less powerful stars. Minor premise, specifically for two stars, the absolute magnitude of Procyon is 0.38, while the absolute magnitude for Rigel is 0.12. What conclusion can you draw from this? The conclusion is Rigel is a more powerful star than Procyon. Why? Because it has a lower absolute magnitude, and as a general concept, we know that more powerful stars have a lower absolute magnitude. How about this one? General concept, major premise, P1. Ornithischian dinosaurs were herbivores. P2, sorry, that should be P2. Stegosaurs were ornithischian dinosaurs. What's the conclusion that must follow logically? That stegosaurs were herbivores. Let me give you an example of a series of deductive reasoning arguments that were used to figure out the size of the universe. Remember back in before 1924, we weren't sure about whether the Milky Way galaxy was the entire universe, or whether it was just one island universe amongst many others, and that those hazy nebulae like the Andromeda Nebula, whether those were actually clouds of gas inside the Milky Way, or whether they were entire galaxies well beyond the Milky Way. And remember, the question turned on how far away are these nebulae, even one of them, the Andromeda Nebula, because the idea at the time was that the Milky Way is 300,000 light years across, and if the nebulae are further than 300,000 light years, they must be separate galaxies. If they're closer than 300,000 light years, then they must be within the Milky Way, and then they're clouds of gas. So the man who solved it was the guy in the middle there, Edwin Hubble, and you remember that he took a picture and observed in the Andromeda Nebula a variable star. And it was actually a Cepheid variable. How did he know that? Here's the curve he recorded about the changing magnitude, the changing brightness of that variable star. And here's how he reasoned. Henrietta Leavitt had already studied Cepheid variables, and we knew that Cepheid variables have a characteristic shark fin light curve that varies over a period of some number of days to some number of weeks. So that's a major premise. It's true for all Cepheid variables. The minor premise, the specific detail that Hubble observed, was that the nova, what he at first thought was a nova in the Andromeda Nebula, had a shark fin light curve that varied over some period of days. What's the conclusion he drew in his big excitement with this is that the nova was actually a Cepheid variable, and you can see that here he's crossed out. He started writing nova and crossed it out and wrote VAR for variable. A little more deductive reasoning. The period of a Cepheid is related to its absolute magnitude by the equation absolute magnitude is equal to negative 2.80 times the log of p minus 1.43. That was originally discovered by Henrietta Leavitt. That's Leavitt's law. The minor premise, the specific detail in this case, was that the Cepheid in Andromeda had a period of 37.5 days. The conclusion, well, you plug that in, this specific detail into the general equation, and you conclude that the absolute magnitude of that Cepheid was minus 5.8. A little more deductive reasoning. The distance to an object in space is related to its absolute magnitude by the equation dpc is equal to 10 to the exponent little m minus big M plus 5 divided by 5. That's a general concept. The specific detail here is that the absolute magnitude of the Cepheid in Andromeda was negative 5.8. We also need to know the apparent magnitude, which can be measured by photometry. And the conclusion we draw is that the distance to the Cepheid in Andromeda, and therefore the distance to Andromeda, was 675,000 parsecs, or 2.2 million light years. And to settle the question of whether the Milky Way galaxy is all there is, we again use deductive reasoning. The Milky Way galaxy is 300,000 light years across, or so they thought at the time. The Andromeda Nebula is 2.2 million light years away. The conclusion that follows logically is that the Andromeda Nebula must be outside the Milky Way galaxy, and therefore it must be an entire separate galaxy.